Question 3 is all about lines and gradients and intersects and all that kind of stuff, so shouldn't be too bad. Let's get started here. We've got to find the gradient of this line AB, this line here. So let's do it up here, question AI, or part 1. So let's do that. We've got 3x plus 2y is equal to 7. So we've got to try and get this 2y on its own on the left and make it somehow a 1y rather than a 2y. So let's see what we can do. Let's take away 3x from both sides. That should put us in the right direction. So we've got 2y equals 7 minus 3x. And then let's divide everything by 2, I think. Let's divide everything by 2. So we get y equals 7 over 2 minus 3 over 2x. And then what we have is this right here is our gradient. So our gradient is this here, this minus 3 over 2. That's what we wanted. 2 marks, not too bad. So let's move on to part 2, or part II. So we have a line that passes through C parallel to AB, so it means it has the same gradient as AB and crosses the y-axis at the point D, and we want to know basically what is the y-intercept of this line that passes through C that is parallel to AB. So for me that looks like, let's write this down here, this part 2. So for me this is y minus y1 equals m of x minus x1. I hope you've seen this before, but if you haven't, this y1 is the y coordinate of the point that we know the line goes through. This x1 is the x coordinate here that we have, and m is our gradient. So I hope you either already know about it or you get the idea. So we're going to go y minus our y1, which is minus 7. So minus 7, so plus 7 is going to be equal to our gradient that we know we have, so minus 3 over 2x, and then, or just minus 3 over 2, and then x minus our x coordinate here, which is 2. So we have that. So let's try and play with this and get it into a form that we recognize. So let's times out, I think let's times out this first. So we've got y plus 7 is going to be equal to minus 3x over 2, and that's going to be plus 3 at the end there, plus 3. Right, next step. Let's take away 7 from both sides to get it. Let's take away 7. So y equals minus 3x over 2, that hasn't changed, and then we're going to have a minus 4 on the end. So like we said earlier, let's use here, so we've got our gradient here, which is the number next to that x, our number there, and then this number here on this line was going to be our y-intercept. So over here we have a different one because it's a different line. This is our y-intercept. So the y-coordinate of D, as they say in the question, is going to be minus 4. So that's our answer for part II, or part 2. So let's move on. Let's go to question B. I don't like this black. Let's change to another color. So the line with equation y equals 1 minus 4x intersects this line. So we've got intersecting lines, so we're going to have simultaneous equations, or at least I think we're going to have simultaneous equations. Let's draw a line here, and let's do it here. So question B here. So we have y equals 1 minus 4x, and then we're going to have the line AB, which is up here, or the line which is here. So let's write that in as well. So let's have y equals 7 over 2 minus 3 over 2x. That's what that is there. So let's label them as well. This is going to be our number 2. Let's go back to purple, and this is going to be our number 1. So there's a few things we can do. You can try and eliminate the x's, or you can try and eliminate whatever you want. What I'm going to do is make them equal to each other, because we have y here and y here. So let's just say that 1 minus 4x is equal to 7 over 2 minus 3 over 2x, because they're both equal to the same thing, therefore they must be equal. So let's try and make things easier. This doesn't look very good at the moment. I'm going to times everything by 2 to get rid of these fractions. So we're going to have 2 minus 8x equals 7 minus 3x. You don't have to do it this way. You can do it any number of ways as long as you get to the same thing. All of them are good in the exam. I'm going to give myself some space here to work with. So let's go for a lighter blue turquoise, and let's add 8x to both sides. Let's do that. So we're going to get 2 equals 7, then minus 3 plus 8 is going to be plus 5x, and then we can take 7 from both sides. If we take 7, then we're going to get minus 5 equals 5x, therefore x is going to be equal to minus 1. So if you got there another way, great. If you got there this way, even better, because this is the way I chose to do it. So we have our x equals minus 1. Let's put that back into one of these equations. Let's put it in here. Our x is equal to minus 1, and then we should be able to get y out of that. So let's go back to this. So we've got y is equal to 1, and then minus 4 times minus 1 is going to be plus 4, so y is going to be equal to 5. So our coordinates of A, I don't know if you can see that, let me go up a bit. Our coordinates of A that we were trying to find are going to be x is minus 1, y is 5, so let me write that here. A is going to be minus 1, 5. So that's good. Right, let me utilize some of the space under here for part C. So nearly done. Part C. So the point E has these coordinates here with 5 and a k that we don't know about. That could be anything. And then given that CE has length 5, find 2 possible values of k. So we've got this 5 here, which is the length of the distance between C and E. It would be quite nice if we could graph this out, but I really don't think I have the time for that on this video. So what we need to do is we need to say, right, we've got the point E and we've got point C, and E is just some place away from C. So if I go up, then you can see the whole question. So the point C is over at 2 minus 7. So the x coordinate is 2, and our x coordinate of point E is 5. So they're a distance of 3 apart. So if we use Pythagoras, then we've got 3 squared plus something squared, so plus something is going to be equal to 5 squared, because that's our distance there. So this is just Pythagoras down here. And our difference there is going to be, what is that difference going to be? That's going to be k. There's going to be some relation between k and minus 7, I think. Where are we? Let's call this a for now. Let's call that a squared. So we need to work out what this is going to be here, this distance. So we've got 3 squared plus something squared equals 5 squared. So hopefully you recognize that, but if you don't recognize that, then you can work it out. But I'm going to tell you now, a is equal to 4, because we have 9 plus 16 is going to be 25. So our a is equal to 4. And then we know that from, let me go even higher up. So we have our k is going to be equal to minus 7 plus or minus 4. If you, like I say, if you can graph this out, it really helps to kind of visualize it. But basically, we've got a point here, and we want to know from minus 7, do we go up 4 or down 4? And this length is going to be 5, this length is going to be 5. and those are the two possible, k can be up here or k can be down here, and we want to know, I don't know if you can see that, let me say that again. So we've got our two distances here, up or down from k, and we want to know which k it's going to be. So we need to give two values for k. So k is going to be equal to, let me do this in another color, k is going to be equal to 7, or minus 7 I should say, this is a minus 7 here, minus 7 plus or minus 4. So k is going to be equal to minus 3 or minus 11. That is the end of the question. I hope you followed me through this scramble a little bit. Maybe it would be good to do a graph of that, but never mind. See you on the next question.